Alright kiddos, today we're going to talk about the parts of the vertex form and how it affects the parabola. You see the things there in your toolbox, how H, A, and K affect it. Let's look at this problem right here. Negative 4x plus 6 squared minus 3. The A, which is 4, actually is negative 4. H is negative 6 and K is negative 3. Gives you a vertex of negative 6, negative 3. Alright, let's talk about the fact that it's negative. The negative makes it a reflection across the x-axis. The 4 means that it is a vertical stretch. When A is larger than 1, the absolute value is larger than 1, it is a stretch, and it is a stretch by a factor of 4. The fact that the vertex is negative 6, 3, when you compare that to the parent function vertex of 0, 0, tells you you're going to move left 6 and down 3. Okay? Alright, so let's talk about graphing specifically. When you are graphing quadratic functions, that means it's something squared. The shape will either be an upside down parabola or a parabola opening down or a parabola opening up. The vertex is always at 0, 0 if it is the parent function. The domain, which is the x value for any parabola, is always from negative infinity to positive infinity. This particular graph has a minimum. If it opens up, that means that it has a minimum because the vertex is the lowest point as opposed to it being the highest point. Axis of symmetry, that's the line that goes down the middle that cuts it in half. In this case, it's x equals 0. It's always the x of the vertex. That's how you write the axis of symmetry. The range, that's the y values. In this case, and that always relates to the vertex. The y of this vertex is 0, and it's going to open up, so we say that y is greater than or equal to 0. Roots, x-intercepts, roots, zeros, those are all the same thing, just means where does it touch the x-axis. Just like we talked about last class, if a is 1, which it is in this case of x squared, it's always going to go start at wherever the vertex is, over 1, up 1, over 1, up 1, 2, 3. And you can verify this using the table on your calculator, and then from there it's going to go over 1 and up 5. So there's not room to do that. And then we're going to graph that using a soft curve. The x-intercept or root in this case would just be 0. And we write it with a little bracket. 0 is the only place this one touches the x-axis. We look at the second one. Now, when we see this equation, x minus 1 squared plus 4, we know that the vertex is 1, 4. So 1, 1, 2, 3, 4. And it's positive. A is positive, so it's going to open up. If it opens up, that means it has a minimum point. The domain, again, is always going to be negative infinity to positive infinity. The vertex we know is 1, 4. We can put the equation in the calculator and find points that way, and I'm about to put those in for you. Or you can use the fact that you know the vertex is 1, 4, and then from there it's going over 1, up 1, which puts it at 2, 5. And then from there it's going to go over 1 and up 3. 1, 2, 3, which is going to put it at 3, 8. Then you would have 0, 5, and negative 1, 8. Again, you can use the table in the calculator, or you can use what we talked about last time about how the parabola increases. x-axis of symmetry goes right straight through the middle, goes through the x-axis, the x value of the vertex, so the axis of symmetry is x equals 1. The range, now this one, the lowest value in the vertex is 4. The y value is 4, so that means the range has to be y is greater than or equal to 4. And transformations, the transformations would be that it moves right 1 and up 4. The solutions would be none, because does this parabola touch the x-axis? No, it does not. Okay, the next one, we have 2 times x minus 3 squared minus 2. So before we even start, we know that the domain is negative infinity to positive infinity. By looking at the problem, you can see that the vertex is 3, negative 2. 3, negative 2. It's positive. The 2 in the front, the A is positive 2, which tells us that it opens up. Now, ordinarily we would go over 1 and up 1, but since this has a factor of 2 in the front, we are going to go 4, 0. So you go over 1 and up 2. Over 1 and up 2. Instead of over 1 and up 1 like you do in the parent function, it's just 1. You go up 1 over 1. Since this is multiplied by 2, you would go up 2. Then from there, instead of going up 3, you go up 6. So we're at 5, 6. And that would put us at 1, 6. Okay, so again, you can just put it in the calculator and figure that out if you'd like. Loose curve there. It opens up. It has a minimum axis of symmetry. Remember, the axis of symmetry goes through the vertex. So it's x equals, the x value is 3. The range, that has to do with the y value of the vertex. So it's something about y and negative 2. And the numbers are going up, so again that's going to be greater than. Transformations, vertex moved to 3, 2, so from 0, 0 that went right 3 and down 2. Solutions, where does it touch the x-axis? Touches the x-axis at 2 and 4. So we would write 2, 4 in the little brackets, or we could say 0, 2, and 0, 4. Those are your solutions, your x-intercepts. Okay. All right, one more. All right, I'm going to go through this one kind of fast. The vertex is negative 3, 1. Negative 3, 1. This one has a negative in front of the parentheses, so that's going to tell us it's going to open down, which means it's going to have a maximum. There's no A, so you're going to go over 1 and down 1, and then from there you're going to go over 1 and down 1, 2, 3. 1, 2, 3, and there's that. Axis of symmetry is going to be x equals negative 3. The range is going to be y is less than or equal to 1 this time. The vertex is at negative 3, 1. The domain, negative infinity to positive infinity. Remember, that's always the same. Transformation, you've got several things here. It's a reflection. It moved left 3 and down 1. And the solutions are going to be negative 4 and negative 2. Alright, so you can use these notes, use your calculator to look at the table as you need to do the assignment. Thanks.